Okay, so we're going to go backwards today. This should hopefully be pretty straightforward. Because we did the derivative of natural logs on, today's Tuesday, on Friday, then today we're going to go backwards, which is take the integral. Now we're not taking the integral of natural logs, we're taking the integral of functions that give us a natural log. So you can see how it's a direct correspondence. Yes? Good. One thing I forgot to, that I haven't mentioned yet that I want to mention while I'm thinking of it, not tonight's homework, but the following homework, we're going to start splitting things in half. Meaning, I'm going to teach the whole lesson today. On Thursday, your homework will be two halves. One half will be wrapping up with this stuff. The other half will be starting the new stuff, and that'll happen pretty frequently. This topic, for instance, doesn't warrant 2 entire blocks, but it does warrant more than 1 block, so I'm splitting the difference. So we're doing like 2 lessons in 3 blocks, if that makes sense. Does it make sense? Good. You're all fairly bright. Let's move on. So, exact same title, except it's a 5.2 instead of a 5.1, and instead of derivatives, we're doing integration.
You posted on school,
It is on school.
I don't see it.
Liar, liar, pants on fire. I'll bet you. What do you want to bet?
$10.
20.
20? It's posted.
No, it's not.
Well, I know, but I didn't unlock it, but it's still in school. So it's not my fault.
Oh, that's my bad.
Yep.
That's a
I'm going to Raisin Cane's for dinner.
Woohoo!
All right, fine, there. Conrad, you want to Venmo me or?
Okay.
You got cash? Okay.
You take my money.
I understand. We are going to delve a little bit into trig functions. So you'll recall, we only know 3 trig integrals. One is sine, well, we know 4 technically. Sine, cosine, and then those other weird ones that made no sense, like secant squared and those kind of things. Today we're going to look at all 6 of them, the big 6. Sine, cosine, tangent, cotangent, secant, cosecant. And they're pretty easy knowing what we know. But there's also a reason why we waited this long. And then you should be able to make a really good grilled cheese. Okay? If you don't use multiple cheeses, you're dead to me. Okay? So at least minimum 2 cheeses to make a good grilled cheese. And you can't be using that thin Wonder Bread crap. You got to get in there with some good quality bread too. And if you're feeling saucy, you could add some type of meat to it, like, oh, I don't know, pulled pork. Grilled bacon. Do you want to fight right now?
Yes.
Okay, let's go. Okay, so we know this already. If we take the derivative of a natural log, I threw those absolute value bars back in there for a reason, which you'll see in a little bit. We just get 1 over x. And if we take the derivative of the absolute value of u, we get u prime over u. So that u prime over u is that thing that I've kept telling you, you got to burn that into your brain. What's the derivative of the natural log? U prime over u, u prime over u, u prime over and over and over again. So today we're going to go backwards. And we're going to focus mainly today on the left-hand part of that. The natural log of x being 1 over x. So it does make it a little bit simpler in my humble opinion. So there it is. If you go backwards, you just get the same thing. The only thing that's worth mentioning is notice that the absolute values bars pop up again. What's the matter?
Someone called my phone.
Oh,
It was Sam Risk. I wasn't sure.
you didn't answer it?
I didn't.
Maybe you could extend your warranty, or you want a trip somewhere.
I know, but I decided that integration was more fun.
Okay. Anyways, so when you take the integral of 1 over x, you get the natural log of the absolute value of x. Why is it an absolute value? Because remember, you can't take the natural log of a negative number. So that'll guarantee that you're not violating any important math rules. Okay? Now notice in number 2, we lose the whole u prime over u thing. Because remember, there's no chain rule in integrals, so we have to figure out a different way to do that. And that's what's going to cause any problem that you might have today is going to come from that. But it's easy peasy. I'll talk you through it. Okay, we good? Yeah, okay. So let's try something simple. Yes? Just had a theorem on that. Good so far? Now, the next step is for those of you that are a little advanced. If you're feeling fancies in your pantsies, you could do this. Bonus. Molly. What? It's a good look for you.
Thank you.
Where'd the absolute value bars go?
It's x squared, so it's going to be positive anyway.
Nicely done.
Thank you.
Are you on my slideshow?
Yeah, but I didn't cheat, I swear.
You didn't read the paragraph at the bottom?
That's too much
Oh, okay.
reading.
Well, you did a good job then.
Thank you.
Hey, it's a lot of big words in that, isn't there?
I didn't even notice.
I
I'm too
understand.
zoomed in.
If you have trouble, Katie can help you with the big words.
Thank you.
Okay. Is the blue necessary? Absolutely not. In the red as your answer, if you're going to leave it in that form, that's okay, but you must have the absolute value bars. That's the thing you got to remember when you're taking these integrals. The blue one is just getting all tricky. And remember, we have a natural log rule. You can bring the exponent up or bring it out from, depending on which way you want to go, and then the absolute value disappears. You could have, if you wanted to, this isn't wrong. You could have done this. That's fine. It's just a little bit overkill. Okay, easy? You're waiting for a big kick in the head, aren't you? Okay, so, as this slide says, common mistake. As you do more and more of these problems, people get lulled into a false sense of security. You see 1 over something, and you think that the integral of 1 over something is the natural log of the absolute value of that something. So this would simply be the natural log of the absolute value of 2x minus 5 plus c. Now there's the mistake. What's the mistake? What did I do wrong, and or what am I missing? Any guesses? Looks good, right? Fits the theorem. The integral of 1 over x is the natural log of the absolute value of x. I got the absolute value bars. It's an indefinite integral. I've got the plus c on there. But the slide isn't called common mistake for no reason. There is a mistake there. Nobody wants to take a chance? Right.
Well, I'm not sure exactly.
Take a chance.
what
Go
the
ahead.
mistake
Live
is,
on the edge.
But I know 2x minus 5, the derivative of that is not 1, it's 2, isn't it?
Uh-huh.
That's all I got.
That's actually
Yeah.
perfect.
Okay, cool.
Okay. This has to be done as a UDU problem. Because again, no chain rule, no quotient rule, no product rule in integrals. And as Greta alluded to, if I take the derivative of the right-hand side, I'm not going to get the left-hand side. Because u prime over u, that would make that 1 a 2, not just a 1. So what I actually needed to do is say u is equal to 2x minus 5. So du is equal to 2 dx. So dx is equal to 1/2 du. This becomes the integral of 1 over u with a 1/2 out in front du, which then gives me 1/2 times the natural log of the absolute value of u plus c. 1/2 times the natural log of the absolute value of 2x minus 5 plus c. It seems trivial. So all of that because of a 1/2? Yes. They are not equivalent values. If I take the derivative of this guy in blue now, I will end up with that. So if that thing is anything other than x, it has to be done as a UDU problem. Make sense? We're good?
Yeah.
Okay. Turn my clicker. Set down right there. Whoosh. Oh yeah. Yeah. Oh. Yeah. No, not scary. Easy peasy, lemon squeezy. Oh yeah. What do you notice? Other than the fact that you want to cry. Conrad, do tell.
The top is the derivative of the bottom.
Ooh, very nice. Therefore? Or was that it? Your thought?
No, that's all I got.
Right, mic drop. What's the matter? Just talking out loud, okay. Any ideas? Why is that relevant, Conrad?
I know U prime over U.
You do.
Yeah.
Uh-huh. What else do you know?
That's about it.
Okay. So you're guessing that we're probably going to get a natural log in here then if you're I don't know how that becomes spouting. You're spouting off of U there?
Yeah.
U prime over U? Emily, what do you got?
You take the you do the UDUs, then you put the last problem.
We do. What's U?
X to the fourth plus 3x. So then when you plug that back into the equation, at the time derivative, it'll cancel out. It's four.
Yeah, I know how to take a derivative. Up until that point, that's a problem you should be able to do. It's a U-to-U substitution. Now, to actually take the antiderivative, however, is where we get into the natural log rules. The antiderivative 1 over u is the natural log of the absolute value of u plus c. Do a little substitution here. X to the 4th plus 3x. Because it happened in the last problem that warrants some discussion, can I drop the absolute value bars in this problem? You're shaking your head no, Atlas. Why?
Because x to the fourth will always give you a positive, but x won't.
Good. Okay. It is now, there is no guarantee that x to the 4th plus 3x will always be positive, so therefore you leave the absolute value bars in there. Okay, rolling right along. Gonna go back to the old split the fraction rule. But this one's a little sneaky. I'm gonna give you a couple seconds to work on that. I will tell you, as the title says, you're going to split the fraction. So try to split that thing up and take an antiderivative. You have 2 minutes, go.
I don't know.
Kind of bummer we could have a cold day tomorrow and not miss this class.
How cold is it supposed to be tomorrow?
Negative 28.
Really?
Why would I lie to you? Have I ever lied to you?
It's 54% chance
Of what?
of cold day tomorrow.
Ooh, where'd you get that data?
Mr. Harmon, he took a weather class one time in college.
One time.
He went to class once.
No, like he took
Oh, he took the whole class.
the whole class for a year one time.
Uh-huh, on how to predict snow days.
Yes, exactly.
And he said,
54% chance because it's gonna be, the wind chill has to be negative 25 or worse.
Mhm.
And it's gonna be negative 25 exactly.
ooh,
In the morning only.
yeah. But that's primo, it's gotta be when people come to school.
Wait,
You don't want people freezing to death on the bus stop.
That's what they're saying, because it takes 5 minutes.
Yeah, anything that puts kids in danger is not good.
I'm in danger if I come to school either way.
There is a major problem with that though, and that is our superintendent is from Wisconsin.
Yeah, my brother had to walk to class at University of Minnesota, which is negative 25 degrees.
daughter lives up there too.
Yeah.
Sorry, I distracted you. Any ideas?
I have an idea.
Oh! Eric has an idea.
So really like this. Where's that best?
I don't know. What'd you do?
Hold it.
All right, hold that thought for a second. Eric's onto something. But before I show you what Eric planned, let me show you what happens when you split the fraction. So when you hear the term split the fraction, normally what you would think is this would become x squared over x squared plus 1 dx plus x over x squared plus 1 dx plus 1 over x squared plus 1 dx. The problem is, the only one of those that you can solve is the middle one. Notice the first one, you do a u du, which would be u would be x squared plus 1, but then it wouldn't cancel because you've got an x squared, not an x. The middle one, good to go with a u du. We did a problem similar to that before. It would seem like the third one would be doable using natural logs, but remember, it's not just the natural log of that stuff. You have to do that as a u du. Okay, so this is bad. However, Eric, I'm giving you full credit for this, came up with an idea. Share.
You combine the last two.
Yeah. Put those two together. X squared plus 1 over x squared plus 1 dx plus x over x squared plus 1 dx. I know the right one is going to work because we just talked about that for 5 minutes. How are you going to take the antiderivative of the left one, Eric?
It's a good question. Using
The left one. You go like this. The L is this one. This guy. How are you going to do the integral of that?
isn't it just the integral of 1?
Bingo. Good. I was afraid you were going to miss that. And then we'd have some big problems. Eric, what is the integral of 1?
X.
Good. Okay, so then changing colors here. U is equal to x squared plus 1, so du is equal to 2x dx. So dx is equal to 1/2 du. So this becomes the integral of 1/2 1 over u du, which is x plus c plus 1/2 times the natural log, the absolute value of that thing, x squared plus 1 plus c. Uh-oh. I've got 2 plus c's. 2c. Thank you for those words of encouragement. What's c plus c? Not 2c.
I thought there's more people.
What's c plus c? Not c squared.
They're both different.
Oh, I thought you were saying it
A
twice.
constant plus a constant equals
Another constant.
another constant. C plus c is just c. Certainly.
Great, so for this one, I don't know if I was like bragging. This is 2x, right?
Yeah.
So why is this not 1 over 2x, it's 1 over 2?
Oh, I screwed up.
So then we have to cancel.
So then, yeah, then whoosh, whoosh.
Are you? So then it would just be 1 over 2. Oh, so.
Yep. I just forgot to write the x there. Thank you.
Yeah, no problem.
Like everything else we've done, if you don't like that answer, you're not sure of that answer, you're in the middle of a quiz and you have some extra time, take the derivative of the final answer in blue. Does it match what you started with? Well, it'd be a little ugly, but you'd have to do some common denominators, but yes, it will end up matching what we started with. Okay, so a different technique when working with this. This idea of splitting the fraction isn't new for us. What is new is the fact that we get down to something that involves the natural log integral, which is that 1 over u business. Okay? Yeah, blah, 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 blah. This will eventually lead us to a fairly common theorem. So now you have to make a decision. Do you just want to memorize the theorem? Or do you want to understand where it comes from? I'm going to show you where it comes from, because in general, I'm not a big fan of memorization. So, you'll recall that when we did differential equations, a differential equation is a fancy way of saying take the integral of both sides. I end up with that beast. Y equals the integral of 1 over x natural log of x. There's no quotient rule, there's no product rule. That looks like it combines both. But if you pick a u, that becomes a solvable problem. The u in this case is the natural log of x. Okay, which I have, I don't know if I did the work or not. There it is. Okay, so I I chose u to be the natural log of x. Derivative of the natural log of x is 1 over x. You knew that already. Solve for dx, I get x du. Do my substitution, and you can already see what's going to happen. That x from the derivative is going to end up in the numerator, which is going to cancel with the x in the denominator. So it becomes this, 1 over u. Well, we know the the integral of 1 over u is the natural log of the absolute value of u plus c. Sub it back in, and yeah, we get that weird thing. The natural log of the absolute value of the natural log of x. Which means we get that as a theorem. For some odd reason, this pops up all the time. I don't know why. I don't know if there's some theorem. I mean, obviously that's the theorem. I don't know if there's some weird physics thing or why this continues to pop up, but yeah.
Where does the first x go? Like this one?
Good question. So if I go back here, I skipped the substitution step, but if I write it out, you'll see it. I'm taking here's my original integral. You figured it out?
Yeah.
Okay, I'm just going to keep going then. Wait till I get up here and expend all that energy writing on the board. That's all right. I need to work on it anyways. Let's take a break for a couple minutes. 2:09. We'll continue with where we're at. Okay, I don't have much more to do except I wanted to talk about the trig identities for the derivative of the clicker, not the word clicker. Okay, so we talked about that, we took a break. Trig functions. Like I said, you know the integral of... I'm here. I see that. You weren't here the whole time.
Yeah, he was.
Nice try.
Yeah, he was.
Yeah, you just missed him.
You just didn't say hi to him.
I mean, he's skinny, but he's not that skinny. Yeah, turn aside. Never. We'll talk later. I'm going to show you where these other ones come from. We're not going to go through all 6, or all 4, I should say, because we know 2 of them already. But why have we waited to do tangent? Because in order to do tangent, you need something crazy like what we just talked about. So how do you do that? Well, let's turn tangent into sine and cosine. Last year in pre-calc, did you do trig identities?
Yeah.
They were one of your favorites, right?
Yeah.
Remember, we're recording. Just say yes.
Yay!
Yeah, I love trig identities. Woohoo! Did you really? There's something wrong with you.
Emily, stop.
Trig identities?
Emily, stop.
I like them.
Emily, stop.
Anyways, rewriting the tangent as sine over cosine, and then picking one of those bad boys to be a u, turns into something like this. I chose u to be cosine of x. I'm pretty sure you could do it choosing u as sine of x, but I did cosine. Take the derivative of cosine to get negative sine. You can see where this is going. The sines will cancel, and we get to, hold on, clicking, that. Okay, that's a big jump. I'll go back. For those of you that are still having trouble with this, the transition goes something like this. Or you could just click on a rant. What am I doing? U is equal to cosine of x. Du is equal to negative sine x. Whoops, x. Dx. So dx. 1 over negative sine x dx. Du, I mean. That will cancel with that. Put a minus sign out in front. This is u, 1 over u du. Make more sense? Beautiful, which gets me to that. And that, as we just learned, is a natural log.
Yes.
Why do you yell every time I click?
I said yes.
Oh,
Gasified.
not yet. It'll get gasified in a second. Now it is. There we go. Realistically speaking, when I ask you to find the antiderivative of tangent, you're not going to go through this whole monkey. Most of you are just going to go home and... Yes, Luke?
Could it also be positive ln sine? Because you could substitute it the other way.
Off the top of my head, I'm going to say no, and I'm going to renege on the fact that I don't think you can choose u to be sine because it puts your cosine in the denominator and becomes 1 over cosine squared.
Okay.
It does not cancel. So we're going to stay with what we know works. Okay. Astute observation. Well done. You get a gold star for the day. Again, you're probably not going to derive these every single time. And most of you have succeeded at being good memorizers, so realistically speaking, you're going to memorize here the rest of them. They all come from the same thing. So cotangent is done by writing it as cosine over sine, picking a u, working it out. Secant is 1 over cosine. You go through, you do all that fun stuff, and you end up with that mess. This seems more practical. When we were doing integrals before, we had obviously the sine and cosine we talked about already, but then you had these weird ones, like when am I ever going to take the integral of secant squared? Well, you're not. It just happens to work out that way. This is more practical because those are the 6 trig functions you've come to know and love. Okay, we're good? Okay, how about now? Yeah. In an effort to stay with my coworkers, you will notice on the next slide it says day 51. But wait, we've already done day 51. So here's what happened. I've been rolling along, giving you the days. We did day 51 already. Then today, Ms. Helene's calc classes didn't meet, so she changed the calendar to stay in line with everybody else. But we're meeting today, and everybody's here. We're one big happy family. So in order to eliminate any confusion, we're going to do 2 day 51. So tonight's homework on Schoology is listed as day 51-B. That way her and I aren't fighting changing the same calendar every other day. Because I was ready to go in there and change them all, like, you know, I'm in charge here, watch this, but then she would have changed it back, and next thing you know, that's how World War started. What's the matter?
So is the answer key then day 52?
Say again, I'm sorry?
What is the answer key?
Ooh, that's a good
52?
question. I didn't
Next
look at the
assignment.
answer. The answer keys are in there, you just gotta, in fact, why don't you do some research, Katie, and let us know. She's on it. Everybody understand the question? If you go to check the answer key, is it?
Yeah. So the answer key says day 52.